All right, guys, this is question number 5 from the 2012 BC exam. And you are told that you've got a bird whose initial weight is 20 grams. And you're given a derivative, and this guy's talking about the rate at which the bird is gaining weight. In part A, it asks if it's gaining weight faster at 40 grams or at 70 grams. So you're evaluating dB dt at B equals 40 and at B equals 70. Okay, pay attention to that. So if you plug a 40 in, you get 1/5 times 60, which is 12. And if you plug a 70 in, you get 1/5 times 30, which is 6. 12 is obviously bigger, so the bird is gaining weight faster when it's 40 pounds. Okay. Part B, it says to find the second derivative in terms of B, and then explain why the graph of B cannot resemble the following graph. Okay, so here's this guy. Okay, there's my first derivative. Okay, I'm going to have to do this implicitly, right? Because B is kind of like Y, all right? So if I remember, the second derivative of implicit always has the first derivative inside of it. So 20 derives away, and then that's going to be negative 1/5 y prime, or in this case, negative 1/5 dB dt. Okay, so I'm here. Now I'm simply going to replace dB dt with what I knew it was initially. So that puts me to here. All right, I didn't really like the way it looked, so I factored a negative 1/5 out and then flipped the guts of my parentheses around, and that puts me to here. Okay? Now, if you think about it, any B value that I plug in between 20 and 100 is going to give me a negative right there, okay? Which means that the graph of B should only be concave down. But this graph here has got some concave up and some concave down. So that's why that can't be the graph, all right? And then part C, it says to use separation of variables to find y equals b of t, the particular solution to the differential equation with initial condition b of 0 equals 1. Okay, I just did an abbreviated version on this video. If you look at some of my previous AB videos, you'll see me work these out in their entirety. But just a quick thought here. You got to get your B's with your DB's and your T's with your DT's. There is no T up there, so you just let 1/5 kind of be in that spot. So I'm here, okay, and you integrate, and you do some steps, and that's what this is kind of indicating. And then when you get to here, I just wanted to point out to you guys, when you E to get rid of the ln that happens, when you E this side, remember he decomposes into e to the ln of 80 times e to the negative 1/5 t, and then from there, you can get your final answer. Okay.